there are a few key takeaways that I mentioned in the process. Number one, I'm not sure if, just to jog your memory, if anyone can remember any takeaway, any key takeaway. Yes? Yeah, under manual testing, we had some key takeaways. There was a takeaway under manual testing? Yeah, so that's true. So there's the element of always destroying everything. I can see people are really sensitive about cost. So that's good that you remember. Yeah. So it was among them. There was one that I mentioned. I think it was the first key takeaway to consider when manually testing your application. Yeah. Say that again. Say that again. Testing HTTP. Yeah, so I mentioned that in the process. So if this is what I mentioned, that when you're testing your application code, it's possible for you to do so locally. It's, however, not possible for you to test your infrastructure code locally. Why? Because as we saw with the Terraform example that we used, your code makes API calls to external providers. So in our case, it was AWS. So for that very reason, it's impossible for you to locally test your code, your infrastructure code. So for you to manually test your code, you have to visualize the entire process, including initializing your infrastructure root module. I'll show you that shortly. And you apply. That means every resource that you have defined as code gets deployed. And number two, once that is done, you destroy. So destruction has been mentioned, but again, just to emphasize, you can't run your code locally, at least for the example that we're looking at. Just not sure I can see myself on the screen. All right. So there's one thing I mentioned about building composable, reusable modules. Just like you do for your application code, it's possible for you to build composable modules that can also be reused. And I mentioned that while also referring to some guy that I'd strongly recommend you check out, Eric Elliott. So as you can see from let me see if I can. All right. It's a bit hazy, but I think that will do for now. If you finding it difficult, there's some screens. So there's one here. I'm not sure there's another one on the other side, but you can use that. So if you look at my project structure, I have a folder here called modules. There are a number of modules that I've written, but I'll focus on just a few, 2 or 3. So the first one is the ASG rolling deploy module and cluster. The second one is the data stores module. So the first one deploys an autoscaling group, and the second one deploys MySQL database. If you remember the design again. Then there's another module under networking that's called LB. So that deploys our application load balancer. So these are the resources that we are going to see how to automate their tests as far as their deployment to AWS is concerned and how Go supports that. Yeah, so let me just open one. All right. Yeah, so this is pretty brief. So as you can see, my provider here is AWS. That's what's on line 4. Line 19 declares my resource. That's the AWS launch configuration. If you've been using AWS, you know that we've switched from launch configuration to launch templates. So you can maybe mark that as a point for update. I'll share the link to the source code. It's available on GitHub for you to fork. All right. Back to the DB. So as you can see here, declaring a resource to deploy a database instance. Just call it example DB. You can try something different. Maybe this might consume your bill. So if there's something lower cost that you can consider, then go for that. Now, whatever you've seen so far is equivalent to a function in your application code, whereby you can write a function or a class for that instance that you can later on include in a given module, depending on the language you're using, and reuse that. So we'll see how we are going to reuse the database module for deploying the MySQL DB and the ASG module for provisioning your autoscaling group. And finally, as you can see here, now I'd like you to take note of a few stuff here. So if you remember the design I shared, among it was the application load balancer. Number 2, so on that note, you can see that on line 9, I'm actually declaring my resource to deploy my load balancer. Now, I mentioned in my previous slide that once you're done building your composable and reusable modules, then you also need to have your example code, which I contrasted with your application code that goes under test. So how does that work? Just above my tree structure, I have my examples code. All right? So I have my examples code that, number 1, will be the infrastructure code under test for the LB. And also, so that's what you're seeing here. And the second one will be the infrastructure code under test for the Hello World app, which in this case I renamed specific to this audience as Hello Gophers app. So on to Go code. So as always, you'll have your test folder. So let me just go to the terminal in a bit. Yeah. So the first things first, if you've done unit tests in Go, you will create a test folder, name it whichever, give it whichever name you like, but just be cognizant of the fact that that will serve as your package. And you will want to do, Go. So once you have, just a question for the audience. So I have some 2 files here. One is go.mod and the other one is go.sum. Anyone with just a mention of what either of those 2 does? Go.mod, go.sum. Yeah. Yeah, so the go.mod will define, the modules that you want to use for your Go code, and the go.sam will include the checksums that, more or less serve as a log file for those modules, so that depending on the specific versions that you've used in your go.mod, then they'll be locked to that version. So the first thing you'll do is create that test folder, give it any name of your choice, and if I open my go.mod folder, then you can see that I have on line 5 a library that's called TerraTest. So for those of you who probably were keen to look at the agenda, the focus was on how to leverage Go to, build a test in an automated fashion. So TerraTest is largely the library, the Go library that I've made use of to help me automate tests for my infrastructure. It natively uses Go just as you use it in your application code. So no much difference. I don't think you'll see anything different from what you use in your application code. So you define on line number 5, the module you want to include. Now here I'm very specific about the version because, and this is a disclaimer for each and every one of us. I've used Terraform as an example, but if you've been following the news, the acquisition of Terraform by what's the company again? I don't think it's by HashiCorp is the parent company, but it was acquired by I think IBM, eh? Yeah. So take note of that specific version because think Terraform. There's a version that I'll check beyond which there's no support for AWS to be specific. So line 5 specifically will install all the requirements you see from line 7 to the very end. But key for you to have in your go.mod file is the TerraTest module. So that will download all the necessary dependencies that are required for you to run your Go tests for your infrastructure. And obviously in your go.sam, you will see all the checksums for locking your dependencies. So this should be familiar to most of us if you've written unit tests in Go. In my package, that is the test package based on the folder name that I gave for my tests, I have of interest to me, number 1 is line 5, the testing framework for Go. And number 2 is line 8. Line 8 comes in handy because having defined TerraTest as the module of choice for me to test my code, there is a helper method that comes with TerraTest. That is called the HTTP helper. There's something I mentioned that I'll repeat because I think it warrants emphasis, that your tests are dependent, all right? That's better. All right. We are dark mode people. We are dark skinned. We are dark mode. Can I still stick with this? All right. That should be Say that again. 80. KT. KT internally, where I work means knowledge transfer. So I think that's what I was I was getting from you. Yeah. So thanks to the library you defined in your go.mod file, we have the HTTP helper. So back to what I was mentioning, that your validations are specific to the type of resource you are deploying. In our case, one of the resources we're deploying is the application load balancer. And if I may just go back to that and my networking module, if you look at line 19, my load balancer listens for HTTP traffic, all right? And for that reason, I have the HTTP helper that is provided by the TerraTest Go library. So that way, it's possible for me to listen in for incoming or even outgoing HTTP traffic and validate if the response that I'm getting is actually the expected response. The other line of interest is line 11, which makes it possible, makes available to me Terraform. Now, why Terraform? It's because entirely my infrastructure as code tool is Terraform, and I need you to take note of something. Most of the definitions here are more or less familiar. This is Go lingo, Go syntax. So look at line 19. So I've made a comment here to say you should update line 19 to point at your module example directory. So just to get the relationship between your modules and your example code, as I'd mentioned in the slide. So when you're writing your application code and writing your tests in Go, the TDD way is to first, create a test, and then obviously it will fail. Look at maybe the compiler message that you're getting, and appropriately create code and a test that will make your test pass, and later on you can refactor. So my application code is what I pass to the parameter Terraform directory on line 19. And as you can see, it points to my example code for the application load balancer on my folder tree. So this is actually what is under test. And from what you can see here, line 16 makes use of what I mentioned, module composition and reusability. Why? Because if you look at line 17, I'm actually pulling everything that is defined within the ALB module under networking. So that makes it easy for anyone, depending on their given use case, to pull in that module and make use of it in such a way that it fits their specific use case. So this is what I was referring to when I mentioned composing modules in the same way you would functions when you're writing your application code. The simpler you make your modules, the easier it will be for you to do it, to test your code. Because you can imagine me having all this code just in one Terraform module. That will be really difficult for me, number one, to keep track of, and number two, to even test. If I go back to my LB test, if you remember, I wish I could go back to my slides. Let me see if I can, just so that we build context. So this is actually what we are testing. So I have my elastic load balancer, in this case, an application load balancer. I have my autoscaling group and my SQL. So the focus for now is the application load balancer. Back to our VS Code. All right. If you remember, I mentioned that one of the things you will validate specific to the application load balancer is the HTTP code that is returned. And among those, we have the application load balancer DNS name. Now, how do I capture this in my Go test code? I do that using variables. So my API consists of exposing variables that I'll make possible to test by using another parameter that the Go testing library, TerraTest, provides you, and that is called the vars. So as you can see, on line 23, I have a variable named ALB name. If you come back to my ALB example up here, if you come back to my application load balancer example, yes, here, you can see that I have defined a variable by the name application load balancer. Sorry, ALB name. So here's the thing. If for any variable you define in your Terraform code for your resource, for you to test that, you have to mix in or pass in the vars parameter in your validation. So for you to make it easy, for you to find it easy to validate, then the Go testing library, TerraTest, provides you with another parameter, vars, that allows you to define all the variables. Now, these variables could be optional, some could be required. So that in your test, you can verify that indeed, when you're listening to HTTP traffic, either outgoing or incoming, then you've captured the correct application load balancer name, in this case, the domain name server name, as will be deployed to your real environment, in this case, AWS. And something else that you probably remember from the slide deck is always remember to clean up everything. Now, you've written Go code, you've probably used defer, all right? You've used defer anytime you want to ensure that, just like you use in some other languages, try catch, defer will ensure that that piece of code must or is always executed. So in our case, because we are very sensitive about our cost, we want to ensure that whether or not our tests fail, that means we've either been successful in deploying our infrastructure to the cloud, or a failure has happened midway. For any reason, we need to ensure that for any created resources on the cloud, they have been destroyed. Otherwise, you will incur costs that are unnecessary. So that is what line 28 does. Again, something familiar to Hugo Gophers. So that comes in after everything has happened. So what comes in first is what I mentioned. You deploy your code. You deploy your resources. That's what you see on line 31. So again, the Go testing library comes in handy with a helper function to help you to first initialize your Terraform code, and once you've done that, immediately apply, meaning deploy all your resources. So that's the first thing that will happen, deploying your resources. If it fails, you'll get, obviously, a failure message. So apply, then destroy. So line 43 explains how the HTTP helper method comes in handy. So basically, the most important arguments that you pass to that helper, number one, the URL of the load balancer. As you can see, I'm capturing that on line 35. Okay, so I'm using familiar Go methods to help me form my URL. So I use the format object on the sprintf method and use the variable that I exposed as part of my API to form the string for my application load balancer name. So you have the URL, you have the expected status, which in this case, if you remember, my definition of the ALB resource in Terraform was 404, and the expected body was 44 page not found. Now, the last two are very important for anyone testing resources or cloud resources that are deployed to the cloud. One of the constraints that you will face when you're deploying, or you may face when you're deploying your resources to the cloud, include intermittency in terms of network. I struggled a bit when I was preparing this demo because I think at some point I was in a place where the connection was not as strong. So for that reason, and remember I say that you can't test your infrastructure code when you're deploying to the cloud locally on your machine. You will be communicating with external dependencies. In this case, AWS. So you'll obviously need to be connected. So you want to ensure that you have, just as you do in application code, made some tries. And that explains line 40 and line 41. So I'm setting the maximum number of retries for me when I'm trying to deploy my application, my resources to the cloud to a given number. And I'm also setting the time between the retries, obviously using Go code that is familiar to you. Beyond the maximum tries, then your test will fail. Now, it's important for you to, having understood the environment you're working in, set a considerable number of maximum retries so that you also do not stretch, your tests that much. Give it a considerable allowance so that you don't have false positives. You see, you can think that your code is performant, yet it's not. Why? Because you've given it an abnormally high number of maximum retries. So just give it something considerable, having understood the environment within which you are working. So that is very important because failures happen because there's a lot of dependency. As we said, you can't purely unit test your infrastructure code because of the dependencies. So the same applies to, so this is a unit test for my LB module, and this one is also a unit test for my Hello Govers app module. The other thing you need to understand is the fact that you can apply mocking and injection in testing your infrastructure. And how you do that is something that I've already mentioned. In some instances, you do not want to use real code, especially where we have dependencies. So for that reason, you can still make use of variables, making them either optional or mandatory, but still ensuring that you can pass mock data to your tests. So I'll just show an example. So if you look at line 21, what I have is a configuration for my database. So that includes the database address and the port. So this is because my Hello Govers app example assumes that my DB is already deployed. That's already a dependency. So how do I mock that to ensure that I can use mock data even if my database is not yet deployed? Expose your API using variables, and you can pass them in as variables in your test, just as I mentioned. So I'll just do, as I wind up, a run for the unit test, because the integration test might take some time. So just give me a sec. Yeah, so I think that the allocated time will be enough for me. So just as a reminder, I have those three. Oh, sorry. Yeah. So I have my three tests. Two are unit, one is an integration test. I won't run the integration test because, as mentioned, it takes some time. So let's run the LB example. By default, Go gives you a maximum of 10 minutes for you to run your code, your tests. Beyond that, your test will fail. So what I'm doing here, having understood that it might take time for me to deploy my resources. If you've created an instance on AWS, then you realize that it takes some time for health checks to be done. It takes some time for a number of pre-checks to be done to your resources. So you need that understanding, and that's why I'm setting my timeout to 30, having understood that Go, by default, will grant me only 10 minutes. Beyond that, my test will fail. So that timeout is important for you. So let's see how that works. Now remember the strategy: apply your code. So that means deploy the resources you've defined. Number two, once they're deployed, and this is for unit testing, once you've deployed your resources, you can clean up after yourself so that you avoid incurring unnecessary resources. As that happens, if you look at line 16, I have two unit tests. Go is gracious enough to provide you a way for you to run your tests in parallel. So if you don't want, assuming you have this as part of your CI/CD pipeline, if you want to build your pipeline faster, then instead of running your tests sequentially, which Go will do by default, then you can run your tests in parallel. So that explains what line 16 does. So if I was running all the three tests, then that will come in really handy. Why? Because the speed at which your tests will run will depend on the slowest running tests and not a combination of the entire time individually the three tests will take. So if you want to make your tests faster, then you can run them in parallel. Now, as you can see, just to explain what happens, there's some initialization happening. Number one, for my backend, that means where I'm storing my state. Number two, for my module. So if you remember, my test points to my example code, which in turn points to my reusable module. All right? So that's what's happening under initialization of modules. Obviously, installation of your provider, in this case, AWS, so that you are able to deploy to the cloud. So the planning is done, telling you what will be created or destroyed or updated in place or otherwise. So in this case, what's going to be created is my AWS load balancer. So let's see how far. What you should see in the test is the validation. So be keen to inspect and see where the validation happens. Again, if you remember, your validation involves listening for HTTP requests, either incoming or outgoing, and ensuring that whatever has been returned is the expected response. So in our case, a 4.4. Also included is the LB, the URL, including the application load balancer name. So I think in like 2-3 minutes, we should have the test complete, and we'll see whether it's a fail or a pass. Good thing, it will automatically deploy. So if I head over to my AWS console, I should see my resource. But that will take some time because I think I was logged out. So you should see your resource. And once your tests are done, immediately your resources will be purged because of the destruction that happens following the destroy command. Yeah, so I think for the sake of time, I'll leave that running as maybe, I'm not sure I'm allowed to take a few questions. I have 5 minutes. All right. Yeah, so if you look at the logger here, you can see that I have my LB DNS name, which was one of the variables that I exposed as part of my API. And again, remember, one of the key takeaways I mentioned was namespacing. So as you can see, I've used a unique ID based on the random.uniqueID method that I called on my in my Go test. So that ensures that in case someone else has named their application load balancer, given it the same name as mine, then that is taken care of. Because random.uniqueID, I think it uses base 62. So that's like the chances of you getting similar IDs is very minimal. So as you can see, my application load balancer was successfully created. So 5 resources were added, and among the 5 resources, one included my application load balancer. After the successful addition of my application load balancer, the next thing that follows, based on the test strategy we saw, was cleanup. Because obviously this is testing. You are not deploying to the cloud for your resources to be there for some time. So that's what's happening right now. So the applied or deployed resources are now being destroyed. And I think, yeah. So as you can see, my tests are passed. And in the same way, you will do integration tests for your different modules. And lastly, if you understand the test pyramid, you will have many unit tests, then you'll have a few integration tests, and at the top of the pyramid, you'll have even fewer end-to-end tests. It's hardly will you find companies or infrastructure engineers doing end-to-end tests, because it's if going back to the test pyramid, it can take some time, but again, it's because unit tests and integration tests will give you largely the value you're looking for. In this case, building confidence so that you're sure that whatever you're deploying to the cloud is the right thing. Yeah, so I'll leave it at that.